Now we're going to look at the last section in 5-7. So this is 5-7, day 3. We're going to look at the Descartes rule of signs. So the number of positive real zeros of f is equal to the number of changes in the sign of the coefficients of f of x, or less than this by an even number. So basically it could be that it changes 3 times, or it could be that it changes 1 time. So you can only subtract by an even number is the rule of this thing. So it's not really as hard as it kind of seems right now. It's a little bit crazy. But the number of negative real zeros of f is equal to the number of changes in sign, of coefficients of f of negative x, or is less than this by an even number. Alright, so let's look at a first example. We're going to use Descartes' rule of signs to determine how many positive, negative, and imaginary zeros there are for f of x equals x to the 6th minus 2x to the 5th plus 3x to the 4th minus 10x to the 3rd minus 6x squared minus 8x minus 8. So we're going to look at the number of sign changes. So if we look at f of x, if we look at f of x, which is what is given there, we can see how many sign changes there are. So this guy's positive, and then he goes to negative. So there's 1 sign change. Then it changes back to positive. There's 2 sign changes. Stays positive. That's the same one. So it is positive. Changes to negative. So there's 3 sign changes. Stays negative, stays negative, stays negative. So f of x has 3 sign changes. So that means that there's 3 or 1 positive real zeros. So why 3 or 1? Because it's equal to the number or the next even number below it. So it's either 3 or 3 minus 2 equals 1. And that's how we get the 3 or the 1. Because I can't take away 4 because that would be negative. So however many even numbers you can take away from it. So then the next thing we have to do is we have to look at the negative. So we have to replace all the positive x's with negative x's. So it takes a little bit of time here because it's a ridiculously long polynomial. All right, and then we reduce everything. So anything raised to an even power is positive. And then to an odd power, this would be a negative times a negative. So that would be a positive x to the 5th, 2x to the 5th. Anything raised to the even power is positive, so that would stay positive. All right, odd would stay negative, and a negative times a negative is a positive. Even would be positive, and then positive x times negative 6 is negative 6x squared. Negative times a negative is positive. And negative 8. So all we did was just reduce basically the negatives. So I forgot the 6. So now we just look and see how many sign changes there are. So positive, 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 negative. So there's 1 sign change. Then it changes back to positive. There's 2 sign changes. Then it changes back to negative. There's 3 sign changes. So we had 3 changes. So therefore, we have 3 or 1 negative real zeros. Okay, so again, it's 3 or 3 minus an even number equals 1. So that's where we get the 3 because there's 3, and then 3 minus an even number is 1. All right, so then we basically make a little chart, kind of like this. So we know that altogether there's 6 because it was x to the 6th power was the degree. So we kind of have to think of the different ways we can make 6 out of this. So we could have 3 positive or 3 negative, 3 positive. All right, so if there's 3 positive, then we use the other negative, which was 1. So we used up 3 for positive, 3 for positive, and then we used the choices from the negative. 3 or negative, or it could be only 1 negative. Well, this only makes 1, 2, 3, 4, so that leaves the other 2 solutions are imaginary. Or now we're going to do 1 positive, 1 positive. Again, we're going to put each of those positives with the choices for negative. So 1 positive with 3 negatives, 1 positive with 1 negative. So again, if we add this up, this is 1, 2, 3, 4. So that means that 2 are left to be imaginary. Or we have one positive and one negative, so that only makes 1, 2, which means 4 of them are imaginary. I understand this is brand new, and it's a little bit hard to get the very first time, so we're going to do this some more in class, but it's really not too bad once you get the hang of it. So let's practice one more time. We're going to determine the possible number of positive zeros, negative real zeros, and imaginary zeros. All right, so again, there's going to be 6 total answers. First, we do f of x. So we look at this. This guy's positive, changes to negative, so there's one sign change. We don't have to worry about all the zeros in between because all those are just going to stay positive anyways, because 0 doesn't have a sign. And then we have this guy stays negative, and then he goes to positive. So we have 2 sign changes. So there's 2 or 0 positive real numbers. How did we get 0? Because we took 2 minus 2, positive real zeros. And that makes 0. And then we have to do f of negative x. So we replace x with negative x. And then we just do anything to the even power would be positive. So this will be positive 2x to the 6th. This is even, so it turns that guy positive. So it would be negative 3x because a positive times a negative is negative. So a negative times a negative is positive, and then we have plus 1. So we have positive, negative, so there's one sign change. Then it changes back to positive, so there's 2 sign changes. All right, so that means that there's 2 or 0 negative real zeros. So we do 0 or 2 positive real, 0 or 2 negative real. Or, so if you think of it this way, make like a little chart. This one, we do 2, 2. And then we give one of them the 2 from the negative and 2 options. And then we do 0, 0. And then we do like this. So I could use both choices for a positive, 2, 2, 2, 2. Why did I write the 2 twice? Because there was 2 choices for the negatives. And then whatever's left over goes to the imaginary. So 2 plus 2 is 4, means that there's 2 here. 2 plus 0 is 2, so I have 4 solutions left. 0 plus 2 is 2, so I have 2 imaginaries. Oops, sorry, 4 imaginaries. And then 0 plus 0 is 0, so all 6 solutions must be imaginary. So those are all the possible number of solutions, okay? So this was what they did before they had graphing calculators. It'd be a lot to just graph it. So what you can do, we're going to do the Descartes rule because we use it in pre-calc and calculus, but you could just graph it, right? And so if a problem on the ACT test is just talking about how many zeros it has or what type of zeros it has, it's easy to graph it and you can just see. So the same sites we've been using in the past. Or remember that app if you have an Android device. Is this. It's actually pretty cool. It looks just like a TI-84. So here's an example. This is 4 zeros. So if we did f of x, I look at this 1, 2, 3, 4. They all stayed the same, so it has 1 positive real 0, right? Because if I take 1 minus an even number, I get a negative number. And then if I do f of negative x, that would be negative x to the 4th plus 6 times negative x to the 3rd plus 12 times negative x squared plus 8 times negative x. And then go through here. This will turn positive. This will go to negative. This will stay positive. And this will go negative. So on this one we have, this is positive, so there's 1 sign change. Changes back to positive. There's 2 sign changes. Changes back, there's 3. So on this one, there's either 3 or 1 negative 0. Right? So here's the positive 0. And there's only 1 negative 0. Right? There could have been 3, but there wasn't. There's only 1. So that means that 2 of them are imaginary. And looking at the graph, you can clearly see what they are, which is a lot easier than having to use Descartes' rule. But we do use Descartes' rule later on in math, so it's good to kind of have this little preview. All right, so tomorrow we're going to do some more problems in class. We're going to use that Descartes' rule. We'll do a couple more of the solving to review, and then We'll look at the graph to see exactly what's going on.